Okay, so let's say I have, hush children, I'm ready to teach you. All right, let's say we have a radical. We have a number on the inside. That little check mark, the sort of house, can be called a couple of things. It could be called a radical. It can be called a square root. And it can be called just a root. The number on the inside is called the radicand. And I'm pretty sure for the purpose of everything you've learned so far, there's never been any number here. Have you guys ever seen a number there in Algebra 1? Okay, yeah. So if there's no number there, it's implied that it is a 2. If there's no number there, it's implied that this number is a 2. And what does that mean? David? Yeah, it's telling us it's the square root of the number inside, or what number times itself will give us the radicand. What number times itself? So a number times itself, that's 2, right? Multiplying by itself. That number by the check mark is called the index. And in Algebra 2, guess what? We're going to change the index. So if I change the index to 3, what does that mean? What number times itself? 3 times gives us the radicand. If I change that index to a 5, what does that mean? What number times itself? 5 times will give us the radicand. Pretty sure for today, everything has an index of 2. For today, everything has an index of 2. All right, we're going to start off by simplifying. Simplify. All right, so my directions are to simplify. Now, don't write this down. I just want to explain. When we're simplifying, we're keeping everything positive. But eventually we'll solve. And when we solve, we can't just keep everything positive. What do I mean? If I have an x squared equals 16, now I'm solving for x, right? Well, that means I would have to take the square root of both sides. Well, what number times itself gives us 16? Positive 4 times positive 4 gives us 16, but what else? Negative 4 times negative 4 gives us 16. So our answer would be plus or minus 4, which is the same as if x squared equals 16 and then you subtract that 16 over and you factor, right? Wouldn't you get that same answer? X equals plus or minus 4. So when we're solving, solving square root method, we always have to account for the positive and negative value. But when we're just simplifying, we only consider the positive form of it because we're not solving for x. We're not saying what could x potentially be. We're just simplifying. So the rule is we will stick with the positive for simplifying. So now I want us to simplify, and now I have the square root of 72. There is no number times itself that gives us 72. So what I'm going to do is I'm going to start breaking this down into factors. And the goal is not to go down to primes. You should have done this a lot in geometry when you got into like the triangles unit, the chapter 9. Right? Our goal is not to break it down into primes. It's to find pairs because the index is 2. Because the index is 2, we're looking for pairs. So I'm going to break down 72. Give me two numbers that multiply to 72. We have a bunch of options here. 36 and 2 is the better option. Did anybody think 9 and 8? All right, 9 and 8 would also work, but 36 and 2 is better. Let's talk about why. We have 36 and 2, and then I can break 36 into 6 and 6, which isn't that a pair? That's why it's getting me the pair quicker. It's getting me pairs quicker. So what we're going to do when we're simplifying, we're going to find as many pairs as possible. 6 was my pair. Can I make any pairs with 2? No. So then what you do is the pair that you found, you're going to put 1 on the outside of the radical. And whatever's not crossed out and not circled, that goes on the inside of the radical. So what's not crossed out and not circled? 2. So what is this telling us? 6 root 2 times 6 root 2 is 72. That's what this tells us. So when we're simplifying radicals, we're saying what number times itself gives us the radicand. 6 root 2 times 6 root 2 will give us 72. Now let's say you simplified the other way. Let's say you went with 72 and you broke it down into 9 and 8. You're still okay. You're still going to get the same answer. It's just going to be a longer way there. 9 is 3 and 3. Is that a pair? Absolutely. 8 is 2 and 4. If I break 4 down, can I get another pair? Yes. So I'm going to break 4 down into 2 and 2. We want twins. We do not want triplets. You're not going to put all 3 of these in a circle together. We just want pairs. We just want twins. We don't want triplets. So now everything we circled goes on the outside 1 time. So a 3 is going on the outside, a 2 is going on the outside, and you multiply them. Whatever's not crossed out and not circled goes on the inside. What's left on the inside? A 2. So this again becomes 6 root 2. Same answer both ways. Yes? No, so I explained that in the beginning. When we're simplifying radicals, we only keep it positive. When we're going to solve using square root method, that's when we put plus or minus to account for both answers. But simplifying, we're keeping it just positive. All right, you all try this one. I do want you to get to the point where you can simplify in your head. I want you to get to the point where you can simplify in your head. The quicker you can simplify, the better. I do not need to see work. I'm just showing you this in case you can't do it in your head. But if you can simplify in your head, that would be better to save time. All right, what are our best options for 24 to break it down into? Dylan. Yeah, I agree. 4 and 6 are definitely our best options. 4 is going to be 2 and 2. Now I'm going to ask myself, if I break down 6, because I can break down 6, will I get any pairs? No. Let's say you did break down 6 because you didn't know. You did 2 and 3. It's fine. What do? Whatever circled is going on the outside how many times? 1 time. But I'm going to put a 2 on the outside, but what do I already have on the outside? A 5. What do you think we're going to do with that 2 and the 5? Multiply them. And now whatever is not crossed out and not circled, that goes on the inside. What's not crossed out and not circled? A 2 and a 3. What do you think we're going to do with that 2 and the 3? Multiply them. So this becomes 10 root 6. All right, let's look at number 4, or number 3, sorry. Here I want us to simplify variables. All variables are greater than or equal to 0, which means what? If they're all greater than or equal to 0, they're what kinds of numbers? Positive. All right, so let's look at this one. If I have the square root of x to the 5th, well, do we agree that x to the 5th is 5 x's being multiplied together? And what are we looking for? Twins. We're looking for pairs. So here's one. Here's another. Everything we circled goes on the outside how many times? 1 time. So 1 x is going on the outside and another x is going on the outside. What's left on the inside? An x. What's x times x? Do not tell me 2x. What's x times x? X squared root x. All right, there's going to be a shortcut here. Let's do another one. Let's say I have, square root of x to the 8th. Isn't that 8 x's? All right, so then I have a pair, another pair, a third pair, and a fourth pair. What's going on the outside? X to the 4th. Anything left on the inside? All right, so let's see this. X to the 8th, the square root of x to the 8th was x to the 4th. The square root of x to the 5th was x to the 2nd and 1x left over on the inside. Who thinks they see a shortcut here of how to figure out what the variable will simplify down to? Vanya, if you see a shortcut, what would x, the square root of x to the 20th be? You got it. If we had the square root of x to the 20th, we would get x to the 10th. Who thinks they see the shortcut here? All right, Ariana, if you see a shortcut, what would be the square root of x to the 11th? You got it. X to the 5th root x. What is the shortcut? David.
It's probably because when you multiply, you're actually adding the exponents. If you were to multiply x to the 10th twice, it would get you x to the 20th.
Yep, so think of it the other way now. You're right. So you're looking at the answer and working back. So what would we do with x to the 20th? Divided by 2. You take your exponent on the variable, you divide it by 2. Whatever that quotient is what your x is in the outside. What is your remainder? That tells you how many x's are left on the inside. So let's say I had x to the 13th, the square root of x to the 13th. So we're going to take 13 divided by 2. 2 goes into 13 how many times? 6. So we have x to the 6 left over. How many x's, I'm sorry, x to the 6 on the outside. How many x's left over? 1, right? 13 divided by 2 is 6. Remainder 1. So it's x to the 6 on the outside and 1x on the inside. Does everybody see the shortcut? Great. All right, now let's add numbers and variables together. All right, so we have 24x to the 3rd. Let's start off with our number first. 24 is going to be 4 and 6. 4 becomes 2 and 2. Is it worth breaking down the 6? No, it's not worth breaking down the 6 because there won't be any pairs. So I'm going to put a 2 on the outside. I have a 6 on the inside. Now I have x to the 3rd. All right, 2 goes into 3 how many times? 1 time. So I'm going to have 1x on the outside with a remainder of 1x on the inside. So here I'm going to have 7ab root 20. Now let's make it different. Let's do root, I don't know. Let's do 75. 75 a to the 10th, b to the 7th. All right, what numbers are you thinking for 75? 25 and 3, you got it. And then isn't 25 5 and 5? Do we agree 1 5's going on the outside? But there's already a 7 there. Since 1 5's going on the outside and there's already a 7 there, what number does that become? 35. We have a 3 left on the inside, and we still have the a and the b's. All right, a to the 10th. Since that exponent of 10 is an even number, are there going to be any a's left over on the inside? No. So a to the 10th, the square root of a to the 10th, we're going to take that 10 divided by 2. It gives us a to the 5th. But isn't there already an a to the 1st on the outside? So now you're going to have a to the 1st times a to the 5th. What's a to the 1st times a to the 5th? A to the 6th. All right, let's keep going now. B to the 7th. 2 goes into 7 how many times? 3 times with how many left over? 1. So 1b is going on the inside. Now we said b to the 3rd, 3 b's are going to the outside, right? 2 goes into 7 3 times, but there's already a b to the 1st. So what's b to the 1st times b to the 3rd? B to the 4th. So we're going to have 35 a to the 6th, b to the 4th, root 3b. Shall we step it up a baby amount? Are we scared that there's a variable in the exponent? Does that frighten us? No, it's the same thing. What was the shortcut? Divide by 2. Same shortcut. 4m divided by 2 is what? 2m. So I'm going to have x to the 2m. Anything left on the inside? No. All right, step it up a little bit more. Scroll down. Do you all agree this is the same as saying x to the 4m times x to the 2nd? Right? X raised to the 4m plus 2 power. That's the same as x to the 4m times x to the 2nd, because when you multiply, you add the exponents. Hey, for some reason, I don't know why, students think this is a lot easier to simplify versus this, even though they're the same thing. Whatever works for you. If it's easier for you to see it, change it into this. Hey, same rule. Take your exponent divided by 2. X to the 4m divided by 2 is 2m. So we're going to have x to the 2m on the outside, nothing left on the inside. The square root of x to the 2nd. 2 divided by 2 is 1. That means an x to the 1st is going on the outside. Is there anything left on the inside? No. Am I allowed to leave my answer like this? No. What's x to the 2m times x to the 1st? 2m plus 1. You got it. All right, next one. So here we're going to have the square root of x to the 4m plus 1. Remember what I said, if it's visually easier for you to figure out what to do when you don't have the binomial exponent, split it. X to the 4m times x to the first. Square root of x to the 4m is x to the 2m, nothing left over. What about x to the first? Any pairs there? No, so it's just x to the 2m root x. All right, you ready to try a couple of these on your own? I have two for you to try on your own. All right, so you do 13 and 14 on your own, and then we'll go over it.
I'm sorry? In the radical, is it supposed to be y 7b plus 2?
No, it's 7a.
Oh.
All right, who has an answer to number 13? David.
X to 3m plus 2 root x.
How many people got that? Good, who needs to see me do this? All right, so number 14 was a little bit different. I switched it up just a bit. Who thinks they have an answer to 14? Matt.
X to the 4a, y 3a plus b plus 1, root x to the a minus the a.
So y to the 3a plus b plus what?
Plus 1.
Plus 1, good. Root.
X to the a minus
I got the same thing. Who needs to see me do this? This is your answer. Nobody needs to see me do it? Y'all got that? All right, good job. All right, I want us to talk about the difference of hold on, what number was that? 14, 15. Okay, so I want to talk about how number 15 physically looks different than the other problems we did. We need to discuss so we understand. All right, how does 15 look different from the other problems we did? Fanya. You're right, we're heading in that direction, but I'm just talking about how it's laid out. So how does this look different from, like, let's say number 14? There's a big main difference here between, like, all the ones we've done so far and number 15. Simon? It's a trinomial. I now have added plus signs in there. I've added addition and subtraction signs. Do you want to know what the biggest mistake is? The biggest mistake is that students think they can treat these individually, meaning they simplify 16w to the third, they simplify 48w squared, they simplify 36w. You cannot split a radical through addition signs. So this is not allowed. So sort of treating them individually. You cannot do that. Remember what I said. Anytime I add pluses, now we're a family. They're linked. I cannot do it. Can I split it through multiplication? Yeah, if it were multiplication instead of addition between those, we could absolutely split it. I cannot split it through addition. So now I'm going to go back to what Vanya said. He said, well, there is a GCF, and that's where we're going to start. What is our GCF? For what? 4W. So now this becomes 4W times 4W squared plus 12W plus 9. Do we agree? Look inside your parentheses. 4W squared plus 12W plus 9. What can we do there? It's a perfect square trinomial, which means we can do what to it? Factor it. So this is going to be 4W times the quantity of 2W plus 3 squared. Do we agree multiplication now? Multiplication between the 4 and the W. Multiplication between the W and the quantity of 2W plus 3 squared. Yes? All right. Can we simplify through multiplication and sort of look at each thing as its own? Absolutely. Square root of 4 is 2. So a 2's coming out. Can I pull this W out or do I have to leave it? Leave it. Now, 2W plus 3 raised to the second power. Isn't this a 2W plus 3 times another 2W plus 3? Aren't those twins right there? So what can I do? I can pull out 1 2W plus 3. If I've lost you, speak up. So we got 1 2W plus 3 pulled out. So what's the only thing left on the inside? A W. All right. I'm okay with you leaving it like this. A 2 times the quantity of 2W plus 3. If you distribute it in, which is also good, you're going to get a 4W plus 6, and then you have root W. But, big but here, the 4W plus 6 must go in what? Parentheses y. Why must the 4W plus 6 be in parentheses versus this? Arish?
Because the root of W is going to the entire expression.
Exactly. This root W is getting multiplied by this whole binomial, which means this is really 4W root W plus 6 root W. Do you see that? Where in this one, it's only showing that the 6 is being multiplied with the root W. Do we see the difference? Right. So if it's a binomial that we pull out, we need to put it in parentheses. We need to put it in parentheses. All right, so moving on, next one, let's talk about simplifying sum and difference. Once again, all variables will be greater than or equal to 0. We could only add radicals if what? Their radicands are the same. We could only add radicals if their radicands are the same. What do I mean when I say radican? Ariana? Good. What's in the radical? What's in the root? Right now, can I add any of these? No. But can I simplify any of these? Absolutely. Before we decide if we can add or not, let's simplify them. So I'm going to go ahead and simplify 18 into 9 and 2. 9 is 3 and 3. So this gives us a 12 root 2. 8 is 4 and 2. 4 is 2 and 2. This gives us a negative 2 root 2 plus root 2. What number is really in front of that last root 2? A 1 root 2, exactly. Can I now add these? Absolutely. 12 root 2 minus 2 root 2 is a 10 root 2 plus 1 root 2 is 11 root 2. All right, you all do this next one. Is that a what?
I had 3 in the second.
45x cubed.
Oh, thank you.
Is that better? Are we ready? Who has an answer for me? Who simplified this down? Chris, what'd you get?
7x cubed root 5xy minus 3x cubed root 5x.
So I got something different. Did anybody get something different? David, what'd you get?
X cubed root 5x minus x cubed root 5xy.
I got something different. Anybody get anything different? Simon?
I got 3x cubed times in parentheses square root of 5xy minus 5x square root 5x.
You got this, minus 5x.
But parentheses around the two brackets. I mean the 5xy. And at the end, yeah.
Like there. I think I still got something different. All right, should we do this one? Let's do it. All right, so let's simplify. So for the first one, we're breaking down that 20 into 4 and 5. 4 becomes 2 and 2. So this is going to be a 2 coming out, but there's already a 2 out there, so that's a 4. X to the third, square root of that brings an x outside, but there's already an x to the second outside, which is going to give us an x to the third. What's left over is a 5xy. Did everybody get that for the first one? All right. Second one, 45, I'm going to go with 9 and 5. 9 is a 3 and 3. I'm bringing a 3 on the outside. Square root of x to the third. 2 goes into 3 one time, but there's already an x to the second on the outside, so that becomes an x to the third. So we're going to have a 5x left over. Everybody get that one? The last one is already simplified. There's nothing else we can do there. So when I go to combine my like terms, I have this one and this one are like terms. How come this second one is not considered a like term with the first two?
There's no y in the root.
Good. There's no y in the radicand. There's no y in the radicand. So now I'm going to take 4x to the third minus 1x to the third. 4x to the third minus 1x to the third is 3x to the third root 5xy minus, we said 3x to the third. Is that right? Yes. Minus 3x to the third root 5x. I think, Simon, what you were doing, you were pulling out a GCF from there. Yeah, and then some, if you took a 3x cubed, then you can have root 5xy minus root 5x. Like that. You don't have to. So I would have left it like this personally. I'm not asking you to factor, right? I'm just asking you to simplify the radical. So you can. So they both have a root of 5x. You can take that out. But then that gets really sloppy because then you're going to be left with a root y minus 1. You would still need that minus 1 there. Do you see what I'm saying? Was that not you, Chris? Was that you or is that not you? Okay, do you see what I'm saying where you would still need that minus 1? So I would have left it at this. Did anybody get this? Okay. All right. Let's keep going.
Leave it there. I put it there for a reason.
You need a life alert.
Alright, just leave it there.
All right, you guys do number 3.
Tease, you're good, it's gone. Tease, it's gone. It's gone.
I'm going to do this step by step. Can somebody tell me what they got for each radical when you simplified? Arish?
For the first one, I got A root B.
Perfect.
The second one, I got B root B.
Perfect.
The third one, I got parentheses A minus B.
All right. Did anybody not get this while simplifying? Are the parentheses here important? Absolutely. Okay. So now, don't they all have the same radicand? So what does that mean? I can add all of their coefficients. So this is going to be A plus B minus the quantity of A minus B root B. I'm going to distribute in that negative. So then we're A plus B minus A plus B root B. What happens with the A's? They cancel. Do I need a parenthesis anymore? No. What's B plus B? 2B root B. How many people got that? Good. All right, we're going to move on to products, and that's the last thing we're doing today. Once again, all variables greater than or equal to 0. So when we're multiplying, very different than adding, right? When we're multiplying, we do not need the same radicand. When you're multiplying, you multiply the coefficients and you multiply the radicands. So here I'm going to have -7 times 5 is a -35. And on the inside, I'm going to have 30 times 2. You can multiply it and make it a 60, or you can leave it 30 times 2 and start breaking stuff up. So 30, we can make that 15 and 2. Why do you think I chose 15 and 2 versus 10 and 3, David?
Because with 15 and 2, you have a pair of 2s.
Good, because 15 and 2, I can have a pair of 2s. You can circle from different branches. That's okay. So now that's going to bring a 2 on the outside. So -35 times 2 is a -70. I can break down 15, but is it worth it to break down 15? Why not? Good. There's no pairs. There's no perfect squares. So here we go. So here I have the root of 6a to the 3rd b to the 8th times 8a to the 5th b to the 3rd. Now, when you're multiplying, could I simplify these if I wanted to? Yeah, you have a choice, and that's really going to be an executive decision on your end. Will it be easier for me to simplify then multiply, or to multiply then simplify? If you simplify then multiply, most likely you'll have to simplify again, right? So you never think you're done simplifying. Always make sure there's nothing else you can do. For these, the numbers aren't astronomical. They're not so big. So I would multiply, then simplify. If the numbers were really big, I might opt to simplify first, then multiply, and see from there. So I'm actually going to multiply these. 16 times 8 is 48. And then I'm going to have a to the 3rd times a to the 5th is a to the 8th. B to the 8th times b to the 3rd is b to the 11th. Now, when I break down 48, 6 and 8 are not my best options. What are my best options for 48, Claire? 16 and 3 are our best options because 16 is a perfect square, which gives us 4 and 4. So I'm pulling a 4 on the outside. I have a 3 left on the inside. A to the 8th, isn't that a perfect square? So the square root of a to the 8th is a to the 4th. B to the 11th, not a perfect square. How many b's are getting taken out and how many are left inside? 5 are getting taken out. And how many are left on the inside? 1. Do I need parentheses around the 4a to the 4th, b to the 5th? No. If there were a plus sign between them, would I need parentheses? Yes. All right. Root 9 times root 9. Well, isn't that just 9 times 9 a pair? So what's root 9 times root 9? 9. What about root 6 times root 6? What's that? When you multiply a radical times itself, what does it become? The radicand whole number, right? The radicand whole number. What about if I had root 121 times root 121? 121. No more radical. All right, well, now what do I do? If I have 2 root d raised to the 2nd power. Is there a plus or minus sign in this radical, or is it a binomial? It's a binomial. When it's a binomial in the parentheses, can I distribute in the exponent? Absolutely. So this is the same as 2 squared root d squared. Well, what's 2 squared? 4. What's root d squared? D. Root d times root d is just d, just the radicand. All right, you all do this, and then we'll move on. I know you guys want to be done. We're almost there. 5 root cd squared. Tell me what you get. All right, who's got an answer for me? Simon.
25 CD.
25 CD. Anybody want to see me do it? All right, so now how does number 8 differ from number 7? If I were to have 2 root y plus 2 minus 3 squared. How does my process for number 7 differ from my process for number 8, and why? Number 7 is what? Kaylee?
Like a binomial, number 8 is like a polynomial, right?
Number 7's a monomial. Number 8 is a binomial.
Yeah.
Because I've added a plus or minus sign, does it change the process? Yes. If it's no plus or minus sign, can I always distribute in the exponent? Yes. The minute I put a plus or minus sign, I am not allowed to distribute that exponent. It's like Algebra 101. We can't make that mistake. So what do I have to do here? I have to FOIL, exactly. Okay, so let's do this. Don't be intimidated. 2 root y plus 2 times 2 root y plus 2. 2 times 2 is 4. Root y plus 2 times root y plus 2 is? Do I need parentheses around there? Yes. Did I lose anybody with this? I need you to speak up if at any point I lose you. Okay, now I have 2 root y plus 2 times negative 3. Isn't that a negative 6 root y plus 2? All right, we're doing it again. Negative 3 times 2 root y plus 2 is a negative 6 root y plus 2. And then negative 3 times negative 3 is a positive 9. All right, I'm going to distribute in this 4. So I have 4y plus 8. Combine negative 6 root y plus 2, negative 6 root y plus 2 is a negative 12 root y plus 2 plus 9. I'm not done. Y. 9 and 8. You got it. So I'm going to have a 4y minus 12 root y plus 9 plus 17. If you wrote, I'm sorry? Oh, y plus 2, thank you. If you wrote 4y plus 17 minus 12y plus 2, that's fine. All right, we're good.